Hey everyone! Welcome back to Pixel Developer, your go-to spot for clean, real-world Android development tutorials. In today's video, we're going to implement Firebase custom notifications using JetpackCompose. The idea is to parse custom notification payloads received from Firebase Cloud Messaging and display that data in the app when the user taps the notification. Before we jump into the code, let's talk quickly about the setup. To make this work, you need to have Firebase integrated both on the client side, your Android app, and on the server side, where notifications are sent from. I've already set all this up, but let me walk you through the essential steps and official documentation in case you're starting from scratch. Here you can see all things which are rewired to set up Firebase notification app. I've already set up Firebase in both the Android app and the server side. The app has the google-services.json file, and the server has the Firebase server key configured. I've also built a custom admin panel using PHP, which lets us send notifications to the app. Now we just need to parse the response from Firebase inside the app. When a notification is sent from the admin panel, it reaches the app through FCM, and we handle it in the Firebase messaging service class. Here we check if the message contains data or notification payload, and then show the notification or perform custom logic based on that data. Now let's set up the Firebase token. I've already done all the Firebase setup and added the required libraries, so we're good to go. First, add the necessary metadata in the Android manifest for Firebase messaging. Then, if you're targeting Android 13 and above, don't forget to request the post notifications permission. This is mandatory for showing notifications. Now, about the token. This is super important. Every device that installs your app gets a unique Firebase token, which acts like an address you can send notifications to. You can get this token using Firebase messaging.getInstance on getToken. Just make sure you're also handling token refreshes, since tokens can change. For example, after the app is reinstalled. Always send the latest token to your backend so your server knows exactly where to deliver messages. I'm using Hilt for dependency injection here, but you can do it in a normal way too. It's totally up to you. Let's talk about notifications in Firebase. Firebase supports two types of messages: notification messages and data messages. This is where a lot of developers get confused, so let me break it down for you. Notification messages are automatically handled by the system when your app is in the background. These messages show up directly in the notification tray without you having to write any code. It's super easy, but the downside is that you can't customize the behavior much. On the other hand, data messages are much more flexible. When Firebase sends a data message, it doesn't trigger a notification by itself. Instead, it lands directly in your app's code and you decide what to do with it. This is really helpful if your app needs to handle some custom logic when it receives the message, like opening a specific screen or updating some data silently in the background. Now, let's see how to parse the data message in your Android app. Imagine the response you get from Firebase looks something like this: image URL, extra data, body, title. We're using data messages, so this data lands directly in your app. Let's break down how to handle it. First, we'll start by creating an intent that will open a specific screen when the user taps on the notification. Here, we're sending the title and message as extras so that you can handle them in the homepage activity. Next, we need to create a pending intent to handle the user tapping the notification. This pending intent will launch the homepage activity. Now, let's create a notification manager to handle the notification. For devices running Android 8, Oreo, or higher, you need to create a notification channel. This is mandatory to manage notifications properly. Next, we build the notification itself using the notification compat.builder. This is where we set the title, message, and add the pending intent that we created earlier. If you want to add an image to your notification, like a thumbnail or banner, you can do so by checking if the image URL is not empty, and then setting it in the notification using big picture style. Now that we've set everything up, we just need to display the notification using the Notification Manager. This will show the notification with the provided data, title, message, image, etc. To avoid blocking the main thread and prevent any crashes, it's best to perform the network operations, like downloading the image, in the background. Now that we have our notification and its data, we need to show this data in the app when the user taps the notification. In the code you've already set up, we pass the title and message in the intent. Let's use that data in the homepage activity. Here we extract the title and message from the intent, which were passed from the notification. Then we display them in text views on the homepage activity. We already created an intent to launch the homepage activity when the user taps the notification. Inside that intent, we pass extra data like the screen name and message ID. Starting from Android 13, you need to ask for notification permission explicitly, or the app won't be able to send notifications. To do that, we first check if the app already has permission, and if not, we request it from the user. This checks if the app has the post notifications permission, new for Android 13 Plus, and if it doesn't, it triggers a permission request. Make sure to handle the permission result in onRequest permissions result. When the user interacts with the permission request, we need to handle the result in onRequest permissions result to check if they allowed or denied the permission. In the homepage activity, we use getStringExtra to retrieve that data and show it to the user. The noTitle part ensures we have a default value in case the data isn't passed correctly. You might want to do more than just display the title and message. For example, you might use the extra data, if passed, to trigger specific actions like opening a certain fragment or updating certain elements of the UI. Now, our main things are done like requesting notification permissions, especially for Android 13 Plus, extracting data from the notification and displaying it in the app, handling the intent and extra data to trigger specific actions within the app, Now that everything's set up, we can send a notification from the admin panel using Firebase Cloud Messaging, FCM. The admin panel sends a post request with the title, body, image, and any extra data. When the notification is delivered to the app, it will show up in the notification tray if the app is in the background, or be handled programmatically if the app is in the foreground. The app will parse the notification data and display it, including any images or custom actions. After sending the notification, check the app to ensure the title, message, and image appear as expected. So everything looks good. The setup is complete, and notifications are working exactly as expected. From sending them through the admin panel to receiving and displaying them in the app with all the data, images, and custom actions, it's all working perfectly.
All right, that's a wrap for this video. I hope you found it helpful. The complete source code is available on GitHub. You can find the link in the description below. If you enjoyed the video, don't forget to like and comment your thoughts or any questions you have. Make sure to subscribe to the channel and hit the notification bell so you never miss an update. And hey, follow us on Instagram for more updates, behind-the-scenes content, and coding tips. Thanks for watching. Keep coding, and I'll see you in the next one. Happy coding.